jet plane lands with a velocity of 100 meters per second and can accelerate at a maximum of negative 9.0 meters per second squared as it comes to a rest. Alright, so let's look at this with a drawing. I need to draw a plane landing. Not very artistic, so I'm going to do something simple. I will start with, this is the body of my plane, and there, the front wings, back wings. And the plane lands with a velocity, so v naught is equal to 100 meters per second. It can accelerate at a maximum of negative 9 meters per second squared. So it's going to slow down at a rate of 9 meters per second squared. That's why it's negative there. So we typically call that a deceleration. Meters per second squared as it comes to a rest. So the plane's somewhere over here, big front wings, little back wings, and velocity is equal to 0 where it comes to a rest. Now let's list our givens. So know the initial velocity is equal to 100 meters per second. The acceleration, it's slowing down, so it's negative 9.0 meters per second squared. And the final velocity is equal to 0. From the minute that plane touches the runway, what is the minimum speed needed before it can come to a rest? Oh, sorry, minimum time needed before it can come to a rest. So in this case, I'm going to look for time. So I need an equation with v naught, a, v, and t in it. That would be this relationship. So here what I'm going to do is I'm going to find, this is for part A, I'm going to find the time. So I'm going to use v equals v naught plus at. So if I isolate t, that means I'm going to subtract both, v naught from both sides. So a times t is equal to v minus v naught. Now according to what I have over here on this side, it says the final velocity is equal to 0. So I'm just going to get rid of that right now. So that means that at is equal to negative v naught, and t is equal to negative v naught divided by a. Well, just looking at this equation, it looks like maybe something's wrong with it. I mean, I've got a negative velocity, negative v naught over a. That's going to be a negative time. I can't have negative time. Well, let's have a little bit of faith here in the math and what we're doing. So let's give it a shot. T is equal to a negative of the initial velocity, which is 100 meters per second, divided by, that's what we're thinking, negative 9.0 meters per second squared. And so now you can see that the two negatives are basically just going to divide out. Or not divide out, I mean. When you put them together, they're going to give you a positive value. So 100 divided by 9, that's going to give me a time of 11.1 seconds. Okay, let's keep going. Let's do B. Can this plane land on a small airport where the runway is 0.8 kilometers long? 0.8 kilometers long. There are lots of ways to go about solving this. So what I'm going to do is I'm just going to figure out how much distance it takes to stop this plane when it lands. And then, well, that would be the 1.1. Yeah, figure out how much distance it takes to stop this plane. And then I'll see if that's 0.8, if it needs more than 0.8 kilometers or less than 0.8 kilometers. So this is B. And this time I'm going to be looking for x. X equals. So if that's true, I also know that x naught is equal to 0. So where it touches down will be equal to 0, and then x will just go from there. Okay, so I need an equation with v squared, a, v, and x. So if I look at this, this will be the v squared equation. That doesn't look very good. V squared equals v naught squared plus 2ax. And I'm solving for x. I'm going to isolate x. I know the final velocity is equal to 0, so I'm going to go ahead and just do that this time as well. I'm going to make that go to 0 and get rid of that altogether. So that's 0 is equal to v naught squared plus 2ax. Okay, start by isolating x. That means I've got to put v naught squared on the other side. So I'm going to move everything kind of around. 2ax is equal to, now I'm going to take v naught squared and move it to the other side. So that's negative v naught squared. Sorry about that. Let's see where we are here. And then what else? Isolating x. So if I divide both sides by 2a, that'll give me x. X equal to negative v naught squared divided by 2a. So that is going to be negative 100 meters per second squared divided by 2a. So it's divided by 2 times negative 9 meters per second squared. Ah, great. Negative divided by negative is going to be a positive, so that's going to work out well. All right. So in this case, when I do the math, it's going to be x is equal to 555 meters, and that is equal to 0.555 kilometers. So if the airport is 0.8 kilometers and I need 0.55 kilometers, then the answer is yes. I'm going to be able to land on the ground at that airport. And then we know